Today we are solving systems of linear inequalities. So we are going to be putting two or more inequalities on the same coordinate plane. So this is like graph the line, decide if it's a solid or dashed line, decide which side to shade, then graph another one on the same coordinate plane, and where those two shadings overlap is the final solution area. Solutions are ordered pairs that work in both inequalities. So if I were to ask you, is the point 0, 0 a solution to the system in number 1? You would have to plug 0, 0 in and see if it made a true statement for both inequalities. If the ordered pair makes a true statement for both inequalities, it is a system. The actual graph of the inequality is a way for us to visually see all of the solutions that we have for that system. This first one is set up pretty nicely to graph. So I'm going to graph this first one. We're going to start at -1 on the y-axis. It's a slope of -3, so down 3, right 1. And I tend to put a lot of points on here because it helps me to get my line to cover the whole graph. Because we're going to be shading, you do want your line to cover the whole graph. So don't just put this in right there and say, there, I'm done drawing my line. Make sure your line is covering the whole graph. Oh, hey, we didn't talk about solid or dashed, did we? This line is a greater than or equal to. That or equal to is going to make us use a solid line. So this is a solid line that we're drawing in. And then greater than, we are going to shade up. So put your pencil anywhere on this line and draw an arrow straight up. Whichever side of the line that arrow is on, that's the side that we're going to shade. If the shade up, shade down doesn't make sense in your brain, that's totally fine. You can also pick the point 0, 0, plug it in. If the point 0, 0 makes a true statement, that's the side of the graph that you need to shade. If the point 0, 0 does not make a true statement, then shade the other side. So if I plug 0 in here, 0 is greater than or equal to -3 times 0 is 0. So 0 is greater than or equal to -1. That is a true statement, so that's the side that we would shade. Now you can just kind of shade lightly. Sometimes I use a highlighter to do this, or I really like on paper, I like using colored pencils because I can choose one color of colored pencil and shade super light on one side of the graph. Okay, the next one, we're going to start at 2 on the y-axis. It's important that you don't shade the first one too dark because you're going to have to put another one on top of the same graph. This one has a slope of 1. Oh my gosh. Phone is blowing up. This one has a less than symbol, which means we are going to use a dashed line. And less than means we are going to shade down. So draw an arrow straight down anywhere on this line. That's the side that we are going to shade. Or you could pick the point 0, 0 and plug that in. 0, 0 creates a true statement. So the side of the graph that 0, 0 is on, that's the side that we are going to shade. The solution of this system is this area on the right portion of the graph where it is double shaded, where both inequalities created solutions. I find this is a great way if you're using a highlighter on a tablet to get out aggression. You can ferociously highlight this area. I have a professor in college that, I had, who was very, very particular. And if we did something like this, he would require that all of the blue and all of the pink be completely erased so that only the final solution was there. Really, he wanted us to sketch one and then do like a final copy where only the final solution is shaded in. I am not going to be that particular. You can definitely have both shadings on there. Just make sure that you find the final solution area and shade that a little bit darker so it's very easy to tell which is the final solution area. When you do this problem on the test on EdSite, you'll graph both of these, and then there's 4 regions of this graph that you could click to shade the solution. You will need to make sure you only click the part that I currently have shaded in yellow. So if I were you, when I'm doing this on EdSite, you could make a really, really simple sketch and be like, okay, -1, a negative slope, that one's going to look something like that. The other one has a y-intercept of 2 and a positive slope. Oops, that one's dashed. And then the first one is shaded up, the second one's shaded down. So this is my solution area. If you have something like that on your paper, you then would be able to look on EdSite and click the right area of the graph for the final solution. Okay, I'm going to put a couple points on this graph. You don't have to put these points on your graph because finding the exact points that I'm choosing might be kind of difficult. But I'm just going to ask you if these points are solutions to the system. Okay, is point A a solution to the system? Why not? It's only shaded by one of the inequalities, not by both of them. How about point B? Yes, absolutely. If I were to take this point, which I think is 8, 1, 2, 3, 4, 8, 5, if I were to plug 8, 5 into both of these inequalities, it would create a true statement in both inequalities. This graph just shows us a whole bunch of points that would meet that requirement. Is C a solution? I'm hearing some yeses, I'm hearing some nos. It's a no. Why is it a no? It's on a dashed line. A dashed line is not included in the shading. A dashed line means everything up to but not including this line is a solution. How about point D? Yes. Yes, because it's a solid line. How about point E? Nope, it's only in the pink, not in both. And F? Definitely no. All right, number 2. The first inequality is not set up very well for graphing, so we need to do a little bit of work to get this ready to graph. What should we do first?
Add the 2. Okay.
Subtract the x, so we'd have -2y is less than or equal to -x plus 4. You could add 2y to both sides and then subtract 4 on both sides. There's a couple different ways that you could accomplish this. Then we need to divide by -2. What happens to an inequality when we divide by a negative? The sign flips. So we have y is greater than or equal to, negative divided by negative is positive, so positive 1/2 x minus 2. And then this other one, y is greater than or equal to 4, that is a horizontal line. So I want you on your own to graph the y is greater than or equal to 1/2 x minus 2, graph the y is greater than or equal to 4, and then we'll check your answer. If you're watching the video, pause the video. The line has a y-intercept at -2 and a slope of 1/2. Solid line, shade up. So that's the yellow highlighter that I used. Then the horizontal line is a horizontal line at 4. It is a solid line and it's shaded up. I used blue for that. And where the blue and the yellow meet, That created green. You didn't know you were going to get an art lesson today, did you? So our final solution area is all of this stuff. And then it kind of curves along with that curved line. Yes. Final solution is where both of them are shaded, where the shading overlaps. Or in number 3's instance, in number 3's case, there's 3 inequalities. So the final solution is going to be where we are triple shaded. Okay, I think of these two, I think number 3 is the more difficult. So let's do the more difficult one, and then we can skip number 4. So number 3, first we've got x is greater than or equal to 1. This is a vertical line. A vertical line at 1. Does it need to be a solid or a dashed line? So let's draw in a solid line. And notice I'm trying to make my lines cover the entire graph. If you use these little itty bitty mini lines, it makes the shading really, really difficult. Okay, and I'm going to use highlighter to shade because it's just easier on my screen. If you've got pencil, I would suggest you put the pencil kind of like sideways on your paper and just shade super lightly. Oh, I didn't really talk about how to shade this, did we? You can't shade up or down on a vertical line. So we want the x values that are greater than 1. X values are bigger than 1 to the right. Okay. Y is greater than or equal to 0. This is a horizontal line. It's a horizontal line at 0. That is the x-axis. They are wanting us to retrace the x-axis. The x-axis has the equation y equals 0. It's greater than or equal to, so this is a solid line, and we are going to shade where the y values are greater, which would be up. Oh, shoot. There we go. Okay. Next, we have this inequality, which is currently not ready to graph. We need to do a little bit of work. First thing we need to do is subtract 4x on both sides. So 3y is less than negative 4x plus 12. Divide everything by 3. Do we need to switch the inequality sign? No, we did not divide by a negative. So y is less than negative 4/3 x plus 4. Don't get confused by that vertical line that we drew. You're still starting at 4 on the y-axis. A slope of negative 4/3. This time it's going to be a dashed line. And which direction are we going to shade? We're going to shade down, which is here. So on this graph, the final solution area is this tiny itty bitty little triangle. Solid line on the left and the bottom, dashed line on the right.